So what about using other bases? We talked about base 2 and base 10, but what about base 3 or base 4? We could represent base 3 actually as a triangle. So you could have a 0 or a 1 or a 2. And if you imagine spinning this around, then it's a bit like a clock. So you could go to 0, you then go to 1, then you go to 2, and then once you get to 2, the next thing is to go back to 0 again. So we would call this a base 3 system, or we would call it mod 3. But we're including 0 in this, so it's got 3 points, but it only goes up to the number 2. If you wanted to refer to a number, let's say 12100 in terms of base 3, it's the same sort of thing that we did in binary. And just to remind you, in binary, if I had the number 1011, then this first 1 is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. And by adding them together, you get 8 plus a 2 plus a 1. So that would be 11. But if we did the same sort of concept but in base 3, then the 1011 would now be 3 to the power of 0. So 3 to the power of 1, 3 to the power of 2, and 3 to the power of 3. So this would be 3 to the 3 is 27, 3 to the 1 is 3, and then we've got a 3 to the 0, which is 1 at the end. So this overall would be 31 in base 3. If we did this in base 10, as we know, 1011, the first one is 10 to the 0, which is just 1. This is 10 to the 1, which is 10. This is 10 to the 3, which is 1,000. And if you did 1,000 plus 10 plus 1, of course, you get 1011, which is the reason that we write them in this way in the first place. It's all in base 10. So in base 10, remember, you could have numbers that go all the way up to 10 in each place. You don't have to write ones and zeros. You could write 1019, for example. But you couldn't write that in binary because you don't have enough. 9 goes up to too many places. So this number here is as high as you can go in binary. But in base 3, of course, we have the choice now of using a 0, 1, or a 2. So in this number here, we have a 1, 2, 1, 0, 0, and these are all 3 to the power of. So you have 3 to the power of 0, 3 to the 1, 9 is 3 squared, 27 is 3 cubed, and 81 is 3 to the power of 4. So to write this number in base 3, you'd have to say it's 1 times 81, which is this part here, and the next part was 2 27s, which is here, 1 9, and 1 1. Oh, sorry, 0 ones. So overall, by adding them together, you get 144 in base 10. So 144 in base 10 is equivalent to 12,100 in base 3. These are equivalent, but in different bases. So this is base 3, and this is base 10. In base 5, you can go all the way up to 4. What would happen if you went up to 5? Well, in the same way that if you go up to 10 in base 10, you carry on to the next column. So if you wanted to work this out in base 5, this is 5 to the 0, 5 to the 1, same sort of thing, 5 squared, 5 cubed, and 5 to the power of 4, and just adding them up in the same way that we did before. So let's have a look at these examples. We've got to convert 412 into base 10 when it starts in base 6. So we'd start off with 412. This is going to be 6 to the 0, 6 to the 1, and 6 to the 2. So there are 2 in the 6 to the 0 column. There's a 1 in a 6 to the 1 column, and there's a 4 in the 6 to the 2 column. So by adding these all together, we would find out what this number would be in base 10. 152. So that means that 412 in base 6 is equivalent to 152 in base 10. Okay, so what about 374 in base 9? So we have 3, 7, 4. In the units column, we have 4, which is 9 to the power of 0. In the nines column, you have 7, so that means 7 nines. And in the 9 squared column, you have 3, which means 3 times 9 squared. So overall, this number would represent 3 times 81, 7 times 9, and 4 times 1. And by adding all of them up, this means 310 in base 10. Okay, finally then, in the last example, 1432 in base 5. So there's 5 to the 0, 5 to the 1, 5 to the 2, 5 to the 3. And this would be 1 times 125, 4 times 25, 3 times 5, and 2 times 1. And by adding them up, we'll find that's 242 in base 10. Okay, next example. Convert each of the following base 10 numbers to the base stated. So now we've got to work backwards. What is 472 in base 4? Well, if we say 472 has to be an amount of 4 to the zeros, it has to be another amount of 4 to the ones, another amount of 4 to the 2s, and another amount of 4 to the 3s. But we don't know how many of these numbers we need. So 4 to the power of 3 is 64. So we know that this has got to have at least 64 in it. What's 4 to the power of 4? That would be 256. So we know that we're going to have a 256 in there as well. But we know that it's 4 to the power of 5 is going to be too high. So we can work out how many of these we need just by referring to, well, if we had 2 of these 256, that would be over 472. So there's only going to be 1 of them. So the number remaining after we take 256 off 472 is 216. So 216, how many 64s go into that? Is 3. So we need 3 of them. So now we have to do 472 minus the 256 minus 3 lots of 64 to find the remaining number, which is 24. And we know that we need at least 1 16 for that. So we'll have one of those 16s, and we'll take away the 16 from the 24 to find that we have a remaining 8. Well, how many of these 4s do you need? You need 2 of them. And then if we take off 2 of those 4s, which is 8, then we're left with 0. So we need 0 of these. So 472 would be 1, 3, 1, 2, 0 in base 4. Let's do the same for part B. So 179 in base 7. So we have 7 to the 0, 7 to the 1, 7 to the 2, 7 to the 3. So 7 to the power of 3 is 343. So we know that we're not going to use that. It's too big. 7 squared is 49. Well, how many 49s do you need? Well, if we did 179 divided by 49, that will tell us that it's 3 point something. So we know then that we're going to use 3 of these. If we took off 3 49s from 179, we get 32. So how many of these 7s do we need? So 32 divided by 7 is going to be 4 and a bit. So we know that we're going to use 4 of these. But what is that extra bit? So far we've used 3 49s and 4 7s. If we take both of those away from the original number, we'll find that we have 4 remaining. And this is the number 1, so therefore we must need 4 of these. Overall then, in base 7, 179 would be 344. Okay, our last example. If we're trying to convert 342 into base 3, let's do the same thing. So 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. Well, what is 3 to the 4 before I go any further? That's 81. So I would probably have to use a 3 to the 5, which is 243. So how many 243s do I need? I know that I need just one. So it's one of those. How many 81s do I need? So if I took 300, well, if I started with 342 and I took away 243, I have a remaining 99. So I know that I need to use just one of those 81s. If I took away 81 from that, I've got 18. So I don't need any 27s to make 18, but I do need 2 9s. And that is actually everything, because therefore I don't need any of these. So therefore 342 in base 3 will be 1 1 0 2 0 0.